it's Professor G, your favorite lab partner, and I'm ready to do part 2 of our first spring lab, simple harmonic motion, SHM 1. All right, so in the last part of the lab, you may have found the spring constant of your spring by graphing data of what happens to the spring as you add more and more force to it. And so as you add more force, you found that the spring stretched more, and the ratio of the force to the amount of stretch turns out to be the spring constant of the spring, which is a great way to measure the stiffness of the spring. So great job. Okay, so I'm looking at my home spring kit set, and I just want to talk a little bit about springs. So I have here the fat spring, and this one is harder to pull than this little spring here. This is easier to pull, and attached to this spring, the easy to pull spring, I have some string and a bag full of masses. Okay, so what we're actually going to study in this lab today is the period of oscillation of this, and this is called a spring mass system because the spring and the mass are both moving together. Okay, so I'm just going to adjust this a little bit. If I pull down on these masses and let go, it's because I'm holding the spring in a bad spot. Okay, let's try that again. So if I pull down on these masses and let go, it's going to start bouncing up and down for a pretty good period of time. And that amount of time it takes to bounce up and then down. 1, 2, 3, 4, 5. There, I just did that. Oh, and we wandered off the screen because I was looking in the wrong place. Anyhow, that was periods of the spring. Okay? And so we're going to see what would affect the period of that spring system. Okay? So we're going to start off with a little brainstorm, and so I'm going to shrink myself down. And just a reminder of what I have out. I have the lab records skeleton out, I have the lab instructions out, and Excel out. So if you don't have those things out yet, go ahead and pause now and get your files ready, and then you can unpause me and continue. All right, got your files ready? Let's do this. The first thing we're going to do is brainstorm what are some of the things that could affect the amount of time it takes the mass spring system to go up and down. How much time does it take for one period? What could affect that? Okay, so we've got a few things that I think are kind of obvious, like what spring you use. That's huge, right? If I use this big fat spring, it's probably going to have a different period than this little guy, okay? But I actually want us to be a little more specific. So what spring you use isn't good enough. What about the spring do you want to study? There's several differences between these two springs. Did you hear I was calling one a big spring and one a little spring? Well, it's because I noticed that if I put these closer, the little one on top is shorter than the big one. So maybe the length of the spring could affect the amount of time. Maybe, what's another difference between these two springs? Can you see the other difference? Yeah, maybe the radius of the spring affects the period. Maybe the stiffness of the spring, which we found out in the previous part was called the spring constant. Maybe that affects the period, okay? Maybe, well, what else can we change, right? What can you change about all these things that are going on? And some things you can't change, like maybe gravity. I can't change gravity in my house, can you? I wish. So gravity might affect the period of the spring, okay? What are some other things? Maybe some of the things that we use in the pendulum lab are going to, remember the angle of the swing for a pendulum? Well, for this, there's no angle. It just kind of bounces up and down. But you know what the equivalent is? It's called amplitude. So if I just hang these masses from the spring like this and they're not really moving, I can measure where is that, and then I can pull down like 5 centimeters and let go. And I've just given it an amplitude of 5 centimeters. Then what if I pull down 10 centimeters? Right? So, amplitude. Let's call it amplitude of pull, just to help us remember like what really that means. Okay, and can you think of a few other things? There's something really obvious I'm totally not listing that you probably think of. Okay, so go ahead right now, pause the video, and fill out the brainstorm. Don't do the what spring you use. That was too general. Specific things either about the spring, about how you're going to pull the spring, or about other things that are attached to the spring, wink, wink. Okay, go ahead and list your brainstorm now. Okay, do you have a few more things on there? All right, what I'm going to grade it is just to see if you were able to add a few more things to our partner brainstorm. Okay, now we're going to fill out our experimental design templates. And there's 3 to fill out. And what I'd like to do is fill these out for 3 things that you actually can test from where you are. Okay, so like I'm looking at my lab materials and I'm like, okay, you know what? I actually can test amplitude because I have a ruler. And so that was actually something I can totally test. So I'm going to write down, okay, dependent variable is going to be period in seconds, just like actually the pendulum lab. And then independent variable, I can measure amplitude. And always lengths, things that you measure with the ruler, you want to measure in meters. Okay, control variables. This is where it gets kind of tricky. This is actually where I'm going to, look at my brainstorm list. I am going to keep the length of the spring and the radius of the spring and the spring constant by using the same spring this whole test. Okay, so I'm going to use the little bitty spring for this. Okay, so I'm going to keep those things the same. Okay, of all of that, what should I list? All right, well, I want to measure the length of my spring. Okay, so I'm going to be using a spring, and I'm measuring the whole metal part of the spring. My spring is 16.4 centimeters, so length equals 0.164 meters. The radius of the spring, again, I use my ruler and measure the radius. The diameter is 0.8 centimeters, so the radius is 4 millimeters, so 0.004 meters radius. And then the spring constant that I got for this, I'll have to look up. What did I get? I got 9.1887. And then spring constant equals 9.1887. And do you remember the units for spring constant? Okay, so those are my values for length, radius, and spring constant. Okay, gravity is, we can just use our 9.8 meters per second. I'm not going to leave Earth to do this experiment. And what else? Let's say any other thing that you brainstormed, you should list here. So I'm going to write down that I'm going to use a mass of 0.170 kilograms. Okay, so at this time, why don't you figure out 3 different independent and dependent variable sets, one for each, and then list the control variables, so that's everything in your brainstorm that you're not changing, and their values, which might require you to measure things like I did now. So go ahead and list those now. Okay, you've got DV, IV, CV filled out. Okay, by the way, if you get stuck, send me questions. I'm happy to help. Okay, Testable hypothesis, just another review where we are, for this one, amplitude effects, period. Boom. Okay. And then for prediction, then you know what I think? I think that if I pull it farther, larger amplitudes, because it has to go farther, I think larger amplitudes will result in larger periods. But you know, if I pull it farther though, it's gonna, the force from the spring is gonna be more, which might make it go faster because there's more force, so maybe larger. If you're not sure, just pick one or the other, and it doesn't matter in the end if you were right or wrong. We just go with the data. Okay, so at this time, what I'd like you to do is to finish filling out the experimental design templates for 3 of your brainstormed variables. Go ahead and do it now. All right, let's answer our design your experiment questions. What are the correct units to use? Okay, so my first independent variable was amplitude, so the correct units for amplitude is meters. Okay, what if for your second independent variable you decided that you wanted to test changing the mass, right, of the spring, okay, on the end of the spring, because you can, then you would want, okay, mass units is kilograms, okay, so the correct units for any sort of mass should be kilograms. And if you, let's see, radius changing would be meters, length changing would also be meters, because those are all measured with a ruler, and so the correct units for things measured with a ruler are meters. And that would leave, oh, what if you wanted to change the spring constant, right? Then that would be in newtons per meter. Okay, so why don't you pause right now and fill out your 1, 2, 3, 4, 5, oops, and there should be a 6 here. Go ahead and fill out all, or just fill out 1, 2, 3 now. Okay, because I just saw number 4 and I'm like, oh, we need to talk. Okay, are any of these IVs impossible to study with the materials available to you? Okay, yes. In fact, most of them are impossible to study. So first, like gravity. If you wanted to change gravity, which I hope you didn't, but if you did, that's impossible. You cannot leave Earth just to do your physics experiment, okay? People do that. They leave Earth to do physics experiments, but usually not college students. Yeah, so, okay. Next, what if you wanted to test length of the spring, right? Well, you've got 2 springs, but is that enough? Is 2 springs enough to do a really good experiment? No. So if you put length of spring or radius, okay, let's be honest, of the spring, or spring constant, because you only have 2 springs, that's not going to work. We only have 2 springs and we'd need 6 to do a good experiment. So if you wrote a template where you wanted to change the length, the radius, or the spring constant of the spring, we can't actually do that based on our lab kits because we don't have enough materials. And that's okay. I don't want you to erase any of your templates. Okay, don't. Okay. All right. Well, so pause right now and go ahead and answer number 4 based on your 3 experimental design templates. Go ahead and answer number 4 now. Okay, and now answer 5 and 6. Go ahead and pause me and answer 5 and 6 now. Tip, the answers are in the instructions. Do it now. All right, so we are going to I am actually going to have you test one of your independent variables for this part of the lab only, okay? So there are a few things that you can measure at home, okay? So you're going to test just one of them. So I'm just letting you know, so pick one of your templates that's left, and that's what you are going to run. For me then, amplitude, I could still experiment on, okay? So let me make this bigger now because we're into the data collection part, okay? So I'm gonna make this bigger. All right, so technically I should have attached, like, I still have my pencil, right? I had like my pencil with the tape on it, and I had the spring attached like this to my fireplace mantle, and then I was doing the experiment, okay? I'm not going to actually be at my fireplace mantle, which is right behind me, during the video, because I realized that my video was really, really sucky when I tried that. So you are going to be doing this with your spring not held in your hand above the camera for effect like I'm doing, okay? What your spring is going to look like is it's going to be hanging off of something like a pencil, sticking out. It's going to be totally still, as no one's arm is going to be shaking it accidentally while it's moving, etc., etc. Okay? So pretty much you're going to have it in the same place you had it for part 1. Okay. All right. So you've got that set up. If you don't, go ahead and pause me here and get that ready to go. Okay. So I'm going to give you some tips and tricks on how to ace this data taking. And the first thing I'm going to do is talk about my data table. Okay. So if you don't have me on full screen, you might want to put me on full screen in case this is hard to see. But I'm testing amplitude. And so I made this data table up, and you can feel free to like copy it if you want. But I have over here, let's kind of hold it here. I'm going to put my amplitude, my first amplitude that I test here. I think it was 5 centimeters. I would write 5 centimeters. And then I figured out the time for 3 periods. And I did that 3 times in a row. So 3 times in a row. And then I averaged these 3 numbers and put it there. And then I divided that number by 3, put it there. This is actually very similar to how you might have done the pendulum lab, where you take several sets of data here and average them, and then find the time for just 1 period. Okay, because finding the time for 1 period originally is really, really hard to do, especially for the spring lab, because if I pull this down, it's moving up and down pretty fast. Like I wouldn't be able to really do a good job with my stopwatch getting this to measure, okay? So right now I'm going to make the spring more realistic, and I'm going to set this oscillating. Okay, what you want to do is let it oscillate for a few times before you start the stopwatch, okay? So you get a good sense of its rhythm, and then I would be like, start, 1, 2, stop, okay? And that time would be the time for 3 periods. And then I would do it again. Start, 1, 2, stop. Okay, and that would be the time for my next 3 periods. And then it's still going, so I go start, 1, 2, stop. And that would be my 3rd time for 3 periods. And then I would write down those 3 times in my data table here, average them, and then divide by 3 to get the average time for 1. And then this number, this column here, and this last column here are the columns that I will enter into Excel. So the way I did the data taking, again, finding 3 periods instead of 1, is because the longer you're using your stopwatch, the better you are at it. You get a sense of the rhythm. 1, 2, 3, stop. You like feel the rhythm, right? That's going to make your thumb hit the stop and the start at the right time. It's not too fast for your thumb to move, okay? These are all why it's just better to do 3 periods than 1. And then why do I set it moving first before I start? You know, like why don't I just go like start when I let go? Start, 1, 2, stop. Well, a few reasons. When you first let go of this, it's a little bit jiggle wiggle. You'll see. You want it to kind of settle in, okay? And that takes like 5 periods or so to settle in. Also, if you think that you are so good that the instant you let go of it, your other thumb presses start at the exact same time, I've got news for you. Nope. What happens is your brain gets a signal from the one hand, I let go, and then the brain sends a signal to your other hand, start, and that's actually pretty slow. like several tenths of a second slow. So you think you might be doing it at the same time, but you're not. Okay, so at this point, what you want to do is for all 6 different IVs, I only had 3 fit on my whiteboard here, but I would have another whiteboard with 3 more. Okay, my computer just tried to go to sleep on me. I am back. Okay, so I would have another whiteboard with 3 more, okay? And so go ahead right now and pause the video and do that data taking, and I'll see you back here when you're done. Are you done? Okay, so what the next thing you're going to do, and I'm going to make my, I'm going to ask Excel very politely to please make that bigger. Okay, is enter in your data. And so here's my data. I studied amplitude into Excel. Okay, and then I'm going to press Command C because I'm on a Mac, but maybe you're on a PC, you'd press Control C or go to Edit and Copy and go paste my data table into my lab records. So go ahead and pause, open up Excel, and put your data in there and paste it into your lab records. Do it now. Nice. All right. So you've got your data into here. All right. Now, this is where we are here in the instructions, your first IV. Okay, calculate the average time for one period of your data. We've done that. We put it in Excel and we did it correctly. And next, what you're going to do is post this data table into the class's Padlet with your name and what your IV is in the title. And that will be you sharing your information with the class, because the class is studying, maybe you studied amplitude like I did, but maybe someone else studied mass, you know, the mass at the end of the spring, and then maybe someone else studied something else. You can post those things onto the class Padlet and then be able to share it, because here's what I want you to do is you are going to get the data tables for the other 2 IVs you didn't test. Actually, and I'm going to rephrase this, editing while on the video for one other IV you didn't test. Okay, one independent variable that we will not be using in Physics 110 is the spring constant variable. So you're just going to pick one other IV, pick data that looks best to you. So if you have one table of your own data and one of a friend, then you should have 2, not 3, 2 data tables in Excel. Your copy of the instructions will be my edited version. Okay, so then you add your Excel data table for that new IV that you grabbed off of the Padlet to your data table. Okay, you might have to have the Padlet open in one side of your screen and type in the data into Excel yourself and then paste it in here. Okay, and you're going to save that Excel file. We're going to use it again in the next lab. All right, now what we're going to do is we're going to first pretend la la la, never happened. Okay, so, and that's number 7 down there. Okay, so now we're just studying 2 independent variables. Let's just answer some questions. Was yours positively, negatively, or not correlated? So just a quick review. I'm looking at my amplitude numbers and they go up 0.5 to 0.35 meters. My periods go 0.9981, so up, then down, then up, then up, then down, then up. That's a big mess. So since it's going up and down, there's no pattern to it. I'm going to say that amplitude is not correlated to period. Now, by the way, this is my data. Your data might have a different conclusion. We're just straight up looking at the numbers, not what's right or wrong. What do the numbers tell you? Okay. How does your data support your answer? as amplitude gets higher or larger, the period goes up and down and up again. No pattern is seen. Okay, so like the periods, blah, blah, blah. In fact, the period hardly changes at all. I'm going to write that too. In fact, the period hardly changes at all. I mean, look at this. My smallest period is 0.9889 and my largest period is 1.002. That's like 100th of a second. That's hardly changing at all. Okay. How confident are you in your correlation? I am really confident here. I am 95% confident that there is no correlation because, you know what gave me the more confidence? Because those numbers for period were so close together and showed no pattern at all. So, I mean, I'm really confident. Okay, so what I want you to do is, well, actually we're pretty much done together, is you're going to answer those 3 questions for your 2 variables that you've got, and then you're going to put it all together into one general claim, and that's it for this lab. Okay, so as usual, please send me questions, and I'm so happy to help, and thanks for being my lab partner.